Okay, um, what I'm doing here is explaining the lab that I'm posting online. Uh, and what the lab requires you to do is you go to a website. This is the beginning of it. It's on the lab. If you download the PDF, just click on that PDF. It should be live and take you to the applet. And your goal is going to be to find the volume of the vase. And we learned volume in class today, so it's just going to be an application of that integral. So what I've done here is I've outlined the vase, just to give you a sort of, so I can try to explain things. And you're treating the graph, the outline of the vase, as a function, that you don't know what the function is. So what I'm going to ask you to do is compute the volume of the vase, and it'll be a volume of rotation like what we did in class, and you'll use this formula right here. Now you need, well, I'll get back to that in a second. And in 1D, you need to use the area of the function to find something else. And I'll leave you to read the problem there. It's the average value, but I'll let you read it. So basically, the problem is that since we don't know f of x, we're going to use Simpson's method to evaluate f of x at these values here. So we're going to use the applet. So you'll use the applet to find f of x0, f of x1, etc., all the way up to f of x6. And then you'll plug it in and use Simpson's rule. Now, a couple of things is the applet only, you can find the x and y coordinates using the applet, but the problem is the applet, as you'll see when you go there, it only goes for whole numbers. So you'll have to, so x0 is 0, that'll be easy. x1 is 33.3. You'll have to go to 33 and estimate. Again, just make an estimate. Don't worry about whether it's right or not, but just make it close. For x2, that would be 66.6, and you'll have to go to 66 and estimate, and so forth. x3 is 100, not 1,000, so that'll be cut and dried. So anyway, what you'll do is you'll figure out what x0, x1, x2, x3, x4, x5, x6 are, and then you'll use Simpson's rule to estimate this integral and this integral. So again, it seems worse than it is. It's not too bad. I've given a lab like this before, and people get it. So I'm sure you'll get it. So the second part of the lab is to do probability. And P of x right here, P of x is what's called a probability distribution. And the integral of P of x tells you the probability that event will occur between A and B. Now that's kind of abstract, so let's do an example. Problem 3 in the lab, it involves problem number 159 on page 346. Again, you're going to do some different things with it than the book asks. So this integral in number 159 is the probability that a car battery lasts between not A months and B months. So this integral right here would be the probability that the battery lasts between 36 months and 48 months, so between 3 and 4 years. So if you do this integral, plug this in your calculator, integrate, the number you get is going to be the probability that that's how long your battery lasts. Now, for example, number 158, which is number 2 in the lab, you're going to have a different example. It's a probability that a sample of ore has between A% and 100 times B% iron. So for example, if A were equal to 75.75 and A is equal to 0.5, what you would have, this would be the probability that the sample has between 50% iron and 75% iron. So the sample is between 50% and 75% iron. So again, I'll let you work with these. I think you'll figure them out. These are just to introduce things to you. So I hope that's helpful. Oops, I need to move this up a little bit since I think I'm off the screen. So again, this last one, problem 158, it's the probability the sample has between 100% A and 100 times B% of iron. Thanks.